All right, ladies and gentlemen, welcome back. Yep, it's another day, another dollar. Probably going to hear the bell in the background, just letting you know. Today's episode is about prime factorization. Okay, and your objective for this is, as a student, you should be able to determine the prime factorization of a number using a factor tree. Now, why are we doing this, Mr. Williams? Well, quite honestly, this is a 7th grade skill, and you know exponents now, you know primes and composites now, and you're going to see this, a lot of you, on your NWEA test really soon. So all of those things are really important. So prime factorization, we're going to go ahead and get started. All right, you're going to need graphic organizer number 6. It looks like this. It's actually kind of a worksheet. You'll finish it and then turn it in. But for now, we're going to do some of these together. All right, so prime factorization, what in the world is it? Well, it's very simple. It's just a way to write a composite number as a product of prime factors. So if you remember the word product, it means multiplying. So basically, you're going to take a number and you're going to reduce it down to small numbers that are all prime, and you'd multiply those prime numbers together to get the other one. Okay? So here's some examples. For example, maybe the prime factorization of 12 is 2 times 2 times 3. Or maybe it's 2 squared times 3. That's using exponential form, which is what we're going to use. Now, that seems a little confusing, but I'm going to show you several different examples. All right, so we complete prime factorization very simply by creating a prime factorization tree, such as, so here we go, example number 1. All right, so I got down here on the side, I've got these prime factor, common prime numbers. Those are going to help us today. Now, we might need some of the other ones, so if you still have your hundreds chart that you did, the sieve of Aristoteles, it'll help you. Okay, so if you still have your numbers, your hundreds chart where you circled the prime numbers, that'd be really important. So here's the deal. We're going to start with the number 36. That's the first one on your list, so that's the one we're going to do. We're going to put 36 at the top of our tree. Now I'm going to put a box around it because that's the one I'm dealing with. Oh, that's an ugly colored box. Let's choose a different color. How about we choose maybe, there's some ugly colors around here. Let's do that color. That's even worse. Whew. There we go. We'll do 36, bright pink. There we go. All right, so what we're going to do is we're going to come up with 2 numbers multiplied together, or 2 factors that you multiply together to get 36. So, for example, we're going to create a tree. So we're going to create our lines on our tree, 2 twigs. What makes 36? Well, I know that 3 times 12 makes 36. Well, that's cool. Are any of those prime? Well, yes, the 3 is prime. So we're going to go ahead and circle it and leave it for a second. What do we do next? Well, 12 is not prime, so we need to continue. Remember, it's got to be all prime numbers. So what makes 12? Well, 4 times 3 makes 12. Are either of those prime? Yeah, 3 is prime again. Okay. What about 4? Well, 4 is not prime. Okay. So what makes 4? Well, 2 times 2 makes 4. Well, guess what? Both of those are prime. Once you get a prime number, your tree will stop. Okay, now we have all primes. There's nothing else for us to continue, so we know that we're done. So really, the prime factorization, you have to be very careful. You want to put these in, you want to put these in order from least to greatest. So we would have 2 times 2 times 3 times 3. Okay, because we have 2, 1, and 2, and then we have 1 and 2. Okay, so we have all of those right there. Now, you guys are smart kids, so you are not going to write it that way. We're going to use exponents. Okay, so 2 times 2 is the same thing as 2 squared times 3 times 3 is the same thing as 3 squared. So this is the answer we should actually have. 2 squared times 3 squared will give us 36, and that is prime factorization. We'll show you a couple more. Okay, let's get started on 55. So what 2 numbers make 55? Well, first put my numbers inside my box, create my tree. What makes 55? Well, 5 times 11 makes 55. I know 5 is prime, so I'm going to circle it. I know 11 is prime, so I'm going to circle it. Hey, those are both prime, so I'm done. So my prime factorization, remember the least to greatest, is just 5 times 11. I don't have any doubles, so I'm not using exponents. That's my answer, 5 times 11. That's the prime factorization. Move on to the next one. Example number 3. We've got 16. Go ahead and put 16. We're going to put our box around it. We're going to create our tree. What makes 16? Well, how about 4 times 4? Well, unfortunately, 4 times 4, none of those are prime. However, 2 times 2 is. So we're going to go ahead and create a new tree. Those are both prime. I'm going to circle. This other 4 is not done. What makes 4? Well, 2 times 2. Guess what? Those are both prime numbers. So we're going to circle those. Hey, listen, we have 4 2's. So this particular case, our answer is going to be 2. And how many do we have? Well, we have 4. So it's 2 to the 4th power. If you guys did 2 to the 4th power, you would get an answer of 16. That is prime factorization. Here goes another one. We have 60. Okay, 60. What makes 60? Well, how about 10 times 6? We'll start there. 10 times 6. None of those are prime. They're not over here on my list. What about 10? Well, 5 times 2 makes 10. Hey, those are both prime. I'm going to go ahead and circle those. And what about 6? Well, 3 times 2. And hey, those are both prime too. Well, look, here we have 1 2 and another 2. So those are both 2's, right? So we've got 2 of them. So those are also our smallest numbers. So we're going to put 2, and we have 2 of them. So it's 2 to the 2 squared times, okay, 3. So that's our next one. So we're done with those. And I cross them off sometimes because they get a little busy. We'll show you one that's going to get pretty hard here in a second. 5. So 2 squared times 3 times 5. Okay. Remember, all of these down here must be prime numbers. There's no other way for you to do it. Prime factorization means you're finding the prime numbers and you're multiplying them together to get another number. All right. Example number 5. Or, sorry, yeah, this should be 5, not 4. This should say number 5. Let's cross that out and make it 5. There you go. Example number 5. We have the number 500. So let's start with 500. All right, we're going to go ahead and put it inside our box. What makes 500? Well, let's start with 5 times 100. Okay? Are either of those prime? Well, actually, yes. 5 is. Let's circle it. We're done with that one. We need to create a tree from the 100. 10 times 10. Are either of those prime? Nope. Got to create 2 trees off those. What makes 10? Well, 5 times 2 and 5 times 2. And I'm pretty sure all 4 of those are prime. So now we have to look at it. We have how many 2's? Because 2's are the first one. So how many 2's? We had 1 here and 1 here. So that means 2 squared. We're going to multiply that by how many 5's? I'm pretty sure we have 1, 2, 3, 5. So it's going to be 5 to the 3rd power. And ladies and gentlemen, that is your prime factorization. We have completed 5 of them. All right, we've completed 5. Your job is to complete the rest of the worksheet, check it on the right side, it is over there, and then turn it in as a graphic organizer. Ladies and gentlemen, good luck. If you need help, come see me as always. Quick video, we're out.